So what is decimal expansion pattern for rational numbers? Let's see the case of rational numbers. As we know, rational numbers can be expressed in the form of p by q, where q is not equal to 0. So decimal expansion is 2 to the base of 10. Prime factors of 10 are 2 and 5. All multiples of 10 can be written in the form of 2 raised to the power of n into 5 raised to the power of m, where n and m are non-negative numbers. For the form p by q, if q is divisible by 2, 5 or multiples of both, then the decimal expansion is terminating. So now we are formulating the theorem for decimal expansion of rational numbers. So the theorem is, let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of p by q, where p and q are co-prime, and the prime factorization of q is of the form 2 raised to the power of n into 5 raised to the power of m, where m and n are non-negative integers. For example, 0.8, which is equal to 8 by 10, can be written as 8 divided by 2 raised to the power of 1 into 5 raised to the power of 1, which is equal to 4 divided by 5. We can see that 4 and 5 are co-primes. Another example can be 0.625, which can be written as 625 divided by 1000, which is equal to 5 raised to the power of 4 divided by 2 raised to the power of 3 into 5 raised to the power of 3, which finally is equal to 5 by 8. And again, we see that 5 and 8 are co-prime. It's about time that we start thinking in an inverse direction. This is a very important pointer. Once we start thinking from an inverse perspective, the same theorem can be rephrased as, let x equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to the power of n into 5 raised to the power of m, where m and n are non-negative integers. Then x has a decimal expansion that terminates. The example can be 4 by 5, which can be written as 4 divided by 5 raised to the power of 1, which is equal to 4 into 2 divided by 2 into 5, which is equal to 8 by 10, which finally is equal to 0.8. So we can see that if 4 by 5 is a rational number where q is of the form 2 raised to the power of n into 5 raised to the power of m, then the decimal expansion of the same terminates. But what if the prime factorization of q is not of the form 2 raised to the power of n into 5 raised to the power of m? N and m are non-zero integers, as I have already suggested. So now the theorem becomes, let x is equal to p by q be a rational number such that the prime factorization of q is not of the form 2 raised to the power of n into 5 raised to the power of m, where n and m are non-negative integers. Then x has the decimal expansion, which is non-terminating, repeating. In essence, it is recurring. For example, 1 divided by 7 is equal to 0.142857142857142857 and so on. Here we see there are repetitions of the digit 142857. In this case of rational number, if decimal is not terminating, then it must be recurring. It's time that you build your retention by visiting WaHPACT.com. Just go to the various courses and try some challenges. Happy learning!